fluid coding and AI. Nemotron 3 Ultra is not interesting because it adds one more row to an open model leaderboard. It is interesting because NVIDIA is claiming the shape of a real coding agent model, huge context, fast decoding, reasoning budget control, tool use training, and open weights. So the useful question is narrower. Can this model stay coherent when the job becomes messy? The benchmark table says Nemotron 3 Ultra is strong. NVIDIA reports high scores on SWE Bench Verified, Terminal, Bench 211, Pinch Bench, Tau Bench, Browse Comp, and Long Context Retrieval. That matters, but it is not the whole story. A coding agent is not a single answer machine. It searches files, calls tools, reads broken logs, edits code, runs tests, gets feedback, and has to remember what changed 10 turns ago. Here is the claim we should actually test. An open model is useful for agentic coding only if it can keep task state across long tool loops, use large context without drowning in noise, respond to reviewer feedback, recover after misleading tool output, and do all of that with acceptable latency and cost. That is a different bar from looking smart in a static prompt. The raw model profile is serious. NVIDIA describes Nemotron 3 Ultra as a 550 billion parameter model with 55 billion active parameters. The Hugging Face card lists up to a 1 million token context window, a hybrid latent Mo architecture with Mamba 2, mixture of experts, attention, and multi-token prediction. It is open weight, but it is not small. The deployment story is just as important as the model card. NVIDIA build lists an OpenAI-compatible endpoint for Nemotron 3 Ultra 55OBA55B, with thinking enabled through chat template settings and a configurable reasoning budget. That gives a harness something practical to tune, not just what the model says, but how much reasoning budget it spends before it calls a tool or writes a patch. The public scores are strong enough to justify a real harness run. NVIDIA reports 71.9 on SWE Bench Verified for the BF16 variant and 69.7 for NVFP4. It reports 56.1 for BF16, T91 for BF16, and 53.9 for NVFP4. Those numbers are relevant because they point toward real software tasks, terminal sessions, and issue resolution. They're still not a substitute for your own agent loop. The long context evidence is also promising, but easy to overread. The Hugging Face card lists a 1 million token context window. NVIDIA reports high ruler 1 million and AALCR scores. That means the model has room for large working sets. It does not mean the harness can dump a repository, logs, stale summaries, and reviewer comments into the prompt and expect attention to solve the rest. There is a speed caveat that matters for coding agents. The technical report says Mamba 2 helps most when the workload is decode heavy, because the per-step sequence cost stays constant. But Ultra still has 55 billion active parameters, so prefill heavy workloads are less favorable. If your harness resends a giant context every turn, you may pay for the large window without getting the full efficiency story. Artificial analysis gives a useful outside comparison with one important label. It evaluated Nemotron 3 Ultra ahead of release in partnership with NVIDIA. It reports more than 400 output tokens per second through Blackbox AI and places Ultra on a strong performance versus time per task frontier for a terminal, bench 2-1 turn budget sweep. That is credible comparative evidence, not a detached community reproduction. The counterweight is that Ultra does not sweep every coding view. Artificial analysis says Gemma 431b is about 1 point higher on its coding index, which includes terminal, bench hard, and scicode. That matters because the real decision is not model size or launch energy. It is task completion per dollar, per minute, and per retry inside the exact harness you plan to use. So the harness should test 4 failure modes. First, a long tool loop, search, edit, test failure, diagnose, second edit, and retest. Second, large context with distraction, a big irrelevant file beside a small relevant bug. Third, reviewer feedback that challenges an invariant. Fourth, bad tool output, like a truncated log or flaky failure where the model has to verify before it acts. The score should not be a vibe check. Record every turn with timestamps, tool calls, observation status, token usage if the endpoint exposes it, retry count, validation state, and final tests. Then grade coherence over tool loops, repo navigation, test-driven recovery, reviewer feedback incorporation, skepticism toward bad observations, tool call reliability, and latency. That turns a model launch into an engineering measurement. My expected result is not a simple yes or no. Nemotron 3 Ultra has the architecture, training story, context length, and public benchmark profile to be worth testing as an open coding agent model. But cheap and fast are not guaranteed by open weights. Serving footprint, context strategy, batching, reasoning budget, retry rate, and provider pricing decide whether the agent is actually efficient. The practical verdict is this. Do not treat Nemotron 3 Ultra as just another leaderboard headline. Treat it as a serious candidate for hard planning, long-running agent work, and recovery turns. But measure it like a system. If the harness cannot preserve state, validate patches, manage context, and control retries, the model cannot rescue the agent system by itself. If you want more videos that test AI coding models as engineering systems, like this video and subscribe to Fluid Coding and AI. The leaderboard is only the first receipt. The real story is what survives the tool loop.